So as I mentioned, this is Web Scraping with Beautiful Soup. I'm Olga. I'm one of the TAs for this class. So to start off, we kind of need to get into what web scraping is. It's the process of extracting data from a website. And as you may know, websites contain a lot of data, but they're kind of hidden away in parts of the website that can be hard to gather. And we could manually get all of this data, but that would be sort of silly given that we have computers, and computers are much better at this sort of menial data collection. And they're faster, more efficient, et cetera, et cetera. And they can also do it for like hours at a time, which humans typically don't want to do or can't do. So today we're going to be learning about Beautiful Soup, which is a Python library for pulling data out of HTML and XML files. So the basic premise is that we have some sort of website and it has all this content on the page and we want to extract some portion of it. So for example, here, let's say we want to extract the yellow box of content. We would parse it through Beautiful Soup, maybe run some methods on it, and then we would get as the output the content that we wanted. And you might be asking yourself, how is that useful? How is that useful? So in the past, what we've been doing, sorry, I just realized I can't see the chat at all. If you have a question, just like unmute yourself and ask it. Let me see if I can get the chat up actually. Okay, well, I have the chat up now. So you can either ask via the chat or in person. Okay, so we've been in this class, we've been using APIs to interact with web pages. So APIs are typically set up either by the website itself or by someone who wants to be able to extract some sort of data from that website. And they make it really handy because you sort of just, you fetch a request and it gives you the information you want back, but not all websites have APIs. And in that case, data scraping can be really useful. Also, as I mentioned before, if you're scraping like a lot of information that you need for research or a data viz, you probably don't want to do it by yourself because that could just take hours. So you can use web scraping to speed up that process and get you to your end result quicker. One concrete example is comparison shopping sites. So Honey is a web extension that I have on my computer, and I'm also a climber. So I've been meaning to buy this hangboard for a while, and you'll notice that here and here, Honey has injected buttons into the page so that they can inform you about your purchase. So here in the middle, they're suggesting that this is the best deal that you're going to get on Amazon. And then on the right, if you click on that, you can see the history of that item over time. So it looks to me as if I'm not going to get a deal on this product anytime soon, but Honey was able to give me this information through web scraping. It wasn't just someone looking up the price of the product every single day for the last 20 days. It was a computer calculating and storing this information. What's Honey again? Honey is a Chrome extension. Chrome extensions, they can inject stuff into the HTML of the page so that you can see whatever functionality they're doing. And Honey, it informs you of, like, it helps you figure out if you're getting the best deal or like if you should wait and maybe get a better deal in the future. Let's see if I can minimize that. So for example, I bought this projector in June. And you can see that it really spiked right about where I bought it, which is a little bit unfortunate. It like before quarantine was like a huge thing. It was like relatively cheap. And then I bought it around when it was like $125. So I like could have saved $30, which was a bit of a bummer to see, but you live and you learn. You can also use it for data viz, as I mentioned. So this is an example where someone took the screenplay dialogue and they broke it down by gender of a bunch of Disney movies. And you can see that significantly more movies have men with 60% or more dialogue than women have 60% or more dialogue. And the way they collected this data was they scraped stuff from movie scripts and then they cross-referenced the characters with IMDb. So it wasn't just like someone reading through the scripts manually and like adding up when men speak versus women. So this web scraping can really, really help you out. As I mentioned, Beautiful Soup is a Python library. Python, it may be a new language to you. It is closer to Java than JavaScript, and the reason why is because it's object-oriented instead of event-driven. It's really useful for processing data, and it does read more like English. So like there's also no semicolons or curly braces, which is a little bit sad, but because it makes spacing and indentation matter, which I don't really like. You'll notice on the right here, it's using a colon instead of the curly brace, and there are no semicolons at the end. Just to be clear, we are getting HTML code and then pulling stuff out of it. Yeah, exactly. I'll touch more on that in the future slides. But yeah, so here's an example of a method, and we have comments with hashtags. The print statement is a lot shorter than Java or JavaScript. It's a very nice language, I would say. In this example, or in this exploration session, I'm going to be running stuff with Jupyter Notebook, which is sort of like this playground where you can type in Python code and it'll run it for you. And you have different cells that you can type code into. And so if you want to do this after the exploration session, here are the things that you want to do. So basically you need to have Python on your computer. You need to have the Python package installer, Jupyter Notebook, and then type Jupyter Notebook into the terminal. Can you guys see the terminal? Yeah, okay, cool. I can never spell Jupyter correctly. It is just like, it always evades me. But so you type that in, and what it should do is pop open a page where you can create new notebooks. So we're going to choose Python 3. And it is just like a playground. So like I can just print hello world, no semicolon, print that out. If I set up a variable like that, it will exist in future cells. So I could do something like print X. And you'll also notice that it shows which order the cells are run in. So like if I were to update one of the cells and run it, you can see it goes 1, 3, 4. This used to be 2, but now it's 4. And you'll note that the result of this cell did not change. That's because it printed X before it had changed to 4. So we would have to run this again for it to be updated to 4. Yeah, so I opened Jupyter up in the terminal. I ran Jupyter Notebook after I had installed all of that stuff. And then so what we're going to be looking at today is this National Weather Service for weather in Seattle. Let's see if I can. So it has information about the weather this afternoon, tonight, Friday, et cetera, has all this information that is just ready for the scraping. So before we can start with anything, we need to do some imports. So Beautiful Soup is a library that is not included in Python, so you need to import it. We also need to import something called requests. Requests is an HTTP library. So similarly to how we were using fetch for HTTP requests in this class, In Python, we use something called requests, and it does sort of the same thing, where page is going to be a response object, and then we're going to pass that into beautiful soup, so it'll create a beautiful soup object for us. So let me copy and paste this stuff. So this is importing beautiful soup. This is importing, make this bigger. This is importing requests, and then this is doing an HTTP request to the website that we want to get our information from. So if we run this, you'll notice nothing popped up. So if you want to see the result of what's inside of a variable, you actually have to include it at the end of the cell. So page, that's not super helpful. So if we wanted to see what was inside of our response, we would do page.content. And now you can see, oh my gosh, we have the HTML. That's so fun. But we can't interact with it yet, right? We need to make it into a beautiful soup object. And then if we put soup at the bottom, it's going to print out what's inside of soup. So now this looks almost identical. The only difference is that now we can use beautiful soup methods to parse information out of this HTML. Are there any questions about this process? Sort of very involved. Okay. So beautiful soup has a lot of methods that we can use to interact with our beautiful soup object. So can anyone guess what this does? Maybe don't read the right side of the slide.
I think it finds all the p tags.
Yeah, exactly. So soup is our beautiful soup object. So if we say find all of the p tags and then run that, look at that. Wow. It found all the p tags and it outputted it to us. And you'll note that it's inside of an array. So this is great and all, but it does have the actual tags themselves and the class. And we kind of want to strip that information because it's not super useful to us. So we can do something like this, where I'll explain this line by line. So what we're doing here, why do we need to import requests again? Yeah, so requests, they allow us to do that HTTP request, because otherwise we wouldn't be able to get the HTML that's necessary to pass into beautiful soup. Will these slides be available? They will be available, yes. Good questions. So what we're doing here is a for each loop. So we're saying this returns an array. For every single paragraph that's inside of that array, we want to print out just the text from that paragraph. So what this means is it's going to strip out this, and it's just going to leave us with the text inside of the tags. And I also added in like a little dashed line so you can see the paragraph sort of separated out. So let's see what that looks like. And it's a lot cleaner, right? It looks easier to read to like a human eye. Yeah. So that is useful. So, and then when we were in the CSS part of this class, we learned about classes and IDs, and now we're going full circle back around. Classes and IDs are super, super useful for web scraping, because imagine you had to find all the content you wanted on the page using just element tags. It would be pretty hard, especially given the way that pages are set up nowadays. There's a lot of the same elements, but the thing that separates them are classes and IDs. So if we wanted to grab just the bolded text, what would be the selector? Feel free to type it in the chat. .temp, yeah. Exactly. And Beautiful Soup allows us to use that same sort of idea to find by ID or find by class, which you can think of very similarly to query selector or find element by ID. So here you can do find by ID, or here, because class is a keyword in Python, you actually need to use class underscore. But let's see an example of that. So if we look at this HTML on the page, we can see that this entire chunk of the page, its ID is 7-day forecast. So if I just steal that and I say soup.find ID equals this, it should print out the HTML of that element, and it does, right? So everything inside of that and the actual div that it's inside of is printed out. And then we can do something similar for a class. Let's see if we can find a class. Panel heading. We could do soup.find class underscore equals panel heading. And then this HTML is a little bit shorter, but it has all of that stuff inside of it. Yeah. So we can also take it a step further. So assuming now we have our 4 paragraph tags inside of this div with the ID outer, and then we have another paragraph tag with the class temp, but it has text that we don't want, what would be the selector to select the bold elements? Feel free to type it in the chat. Div.temp, yeah, outer.temp was the one that I was thinking of, but div.temp would also work. We can do something similar in Beautiful Soup as well. So select is a little bit more general than find. In select, you can do all sorts of CSS selectors. So you can do direct children of elements. You can do the nth up type. You can have an ID followed by a class, or you can even have like comma separated. So, oops. So for example, if we were to select the period name, so that would be inside of, what was it? 7-day forecast container is, where is it? I'm not sure where that one is, but we're looking at the period name. So that would be, oh, here it is. Here's the forecast container. Inside of that, we have, keep going, the period name. So that would be, we would be grabbing this piece of information. Any questions about selectors? Okay, so moving on past that, we're introducing pandas. Pandas is not the furry creature, unfortunately. Pandas is a Python library for data manipulation, and it's very useful for in conjunction with Beautiful Soup, because you can make something called a data frame. So a data frame is a table of values, much like an Excel table. So on the right, you can see we have the first, last, and favorite pet columns, and then we have rows 0 through 2. Data frames can be manipulated, but in this exploration session, I'm just sort of going to talk about how you can make these data frames so that you can later convert them into CSV files. So Pandas is another library, so you have to import it. They will always return an array, right? Or they also return. Are you referring to selectors return an array? For the most part, so find all will return an array. Selector and find all. Find all will return an array. Select, it depends on how many elements meet that requirement, I believe. And then find will just return one. Good question. So you have to import pandas. It's another library. Then you create the data frame by doing pandas or pd.dataframe, and then you give it the column name and then all the values that go inside that column, and then you do that for all of the columns inside of the data frame. So here you can see first corresponds to this column name, and then we go down the line. And we can see that everyone's favorite pet is a cat, which is the correct answer. So if we grab this line of code, plop it into here, and then we run df, we can see we've created that data frame. Yes, I think there's too much pro-dog propaganda in this class. I would like to rise up and say that cats are better, but Tal didn't hear me say that. Yeah, Tal's not here, so this is unbiased opinions. So we have this data frame, and that's great and all. It looks pretty. It looks nice. But as I mentioned, we are using the data frame sort of as a stepping stone to get to CSVs. So with data frames, you can convert them to CSVs using this function. We're saying here it has two parameters, or it has many other parameters, but we're just going to use two. The first one is the path of that CSV file. If it doesn't exist, it'll create it for you. The next one is whether we want the index of the rows to show up. So that's 0, 1, and 2. Most of the time, I don't really want that to show up in my CSV, so I just have the index be false. But if you ever want to, you can say true there. So if we take this line of code, we run it. Okay, so now what? Where did it go? So remember that we're inside of this Jupyter environment. Yep, let's leave it. And it's exported it to the same sort of directory that we were running our Jupyter notebook in. So it's right here. And if we click on it, ooh, wow, it made us a CSV with that information. So for this example, it's a little bit basic, but you can imagine if you had many other columns and rows, this would be useful because CSVs are sort of like the most used data type for the most used file type for data, or very, very widely used. So CSVs are good for interacting with data. Are there any questions about pandas, data frames, CSVs? Okay, I'll move on then. So that was cool and all, but let's do an actual example. So let's say that we want to collect these 3 pieces of information for every day of this week's weather, and then put it into a CSV. So 3 pieces of information are day, temperature, and description of the weather. So what steps do we need to take? This is where I'll introduce my 3-step plan to successful web scraping. Part 1 is perhaps the most boring one because you're not really doing any hacking, you're just kind of looking at the website. But it is super crucial, otherwise you don't really know what classes or IDs or elements you're supposed to be looking for. So you need to understand what the website looks like before you can start like grabbing stuff from it. So if we look at our 7-day forecast, seeing as how I made the example, I already know where we could find this information. It's inside of this chunk, right? So this would be the day. They split it into like Friday day and Friday night, which I don't love, but what kinds of information are we allowed to scrape? That's a great question. So maybe I'll touch on this later, but basically web scraping is if you do it too much on one website, they might end up blocking you. If they get too much activity from one IP address, they might block you. So I think in general, any information that's sort of on a public website is safe to scrape. The extent to which you scrape is like a gray area. There are actually companies that scrape websites and then put all that information into like docs and then give it back to the company so that they can like improve their sales or whatever. But in general, I would tread lightly with web scraping. Make sure you're not like scraping anything that's sensitive. This is just like a weather website, so it seems fine, but like make sure that you're like thinking ethically about what you're scraping and then like what you're using that data for. That's a good point though. Are there any legal restrictions? Ooh, I'm not totally sure. I feel like in the past people have gotten in trouble for like scraping stuff that they shouldn't have, like maybe if they hacked into something. If anyone knows of any examples of that, I don't know off the top of my head, but like if you're not scraping too much, it should be fine. What if I was using this data for my own website that I make? That should be fine. I mean, as always, you should probably like sort your cite your sources so that you're not just like stealing someone else's data and then you're passing it off as your own. Yeah, good things to consider. So the 3 pieces of information were day, temperature, and description of weather. So conveniently, you'll find that those 3 pieces of information are right here for each day. So we kind of know what we're looking at. We want to be grabbing this period name class, this short description class, and then this temp or temp high class. And then we want to be grabbing maybe this ID before we grab everything else. With web scraping, the idea is sort of like you want to be as specific as you can with your selections because there might be other elements with the same class on the page that you grab that you don't actually want. So like, I don't know, class temp, maybe that appears somewhere else on the page and you're not aware of it. So if we just grab the 7-day forecast container, we know that all of the things that we scrape are going to be restricted to that section. So we won't need to worry about any extraneous data. So that feels like we've got kind of a good idea of what we want to be scraping. Part 2 is actually grabbing the HTML. So let's go back here. Let me grab this line of code. We can actually start a new notebook just so things are a little bit cleaner. So we're doing that HTTP request. We're grabbing that page, and then we want to make our beautiful soup object. So we pass in and then HTML parser. So that gives us what we want to work with. So now, let's say that our first selection is we want to grab the 7-day forecast container, as I mentioned, so that we're not sort of grabbing anything extraneous. So, so we could do that by setting it equal to something. let's say 7, and then soup.find, we can do by ID. There are many different ways to also scrape. So like right now, I'm just doing what comes to my mind. You could do it however you want to, as long as you're getting the information you want back. So I want to get that. I want to get that element. Let's make sure we actually got that element, and that looks right to me. So now what we can actually do is, instead of doing soup.find, soup.select, etc., we've narrowed down what we want to be indexing into to just this 7. So now we can run the same methods on 7 as opposed to soup. So so the first thing we want to grab is the period name, right? So let's maybe name that names. And so we do 7 dot, we could do another find, right? Because it has the class period name. So class underscore equals period name. Cool. So, oh, whoops. What did I do wrong here? It's only returning one element. Yeah, so I want to be using find all. Find will just replace, or will just find the first iteration of that, but we want all of them. So set that equal to. So now we have all of it. So like the problem we had before, we are getting we're getting the elements, we're getting the class and the text, but we only want the text inside. So we can do a little tricky Python syntax here, and we can set it to, let me just type it out and then I'll explain it. So we're doing a for each loop. So we're saying for every single name in names, so that means for every single one of these elements, we want to return just the text. We want to grab just the text. So if we're going down the line, we're saying for the first one, we want to grab just the text. For the second one, we want to grab just the text. And then by putting it in brackets, what we're saying is we want to make an array out of all of these values that are being returned. It's not super important that you know like the Python syntax, just as an explanation of what's going on here. So now when we print out names, we can see it has that information that we want. And then we repeat this process for the other two pieces of data that we want to find. So let's see. We also want the description. So we can just grab the class short description. Descriptions is 7.find all class. I see it and then I immediately forget it. Short description. Let's print out what that looks like. Oops. Yeah, okay, so now you want to do something similar with what we did with names, where we're setting it to description.text for every description in that array. Let's print it out. Okay, so we've got that array, and then we do this one last time with the temp. So I'm seeing a class temp and I'm seeing a class temp high. Does anyone know which one we want to use for this? Maybe if I open up the other containers, we can sort of see temp. Yeah, exactly. So if we only did temp high, we would only be getting the temperatures that are the high of that day. So it would be 73, 76, 81, 90. We want all of the temps. So we use the temp class. Yeah, exactly. So we say temps 7.findAll class is, I just cannot remember these, temp. And then let's see what temps looks like. Yep, now we want to set it equal to, what's the temp.text or temp in temps. And then print it out. Cool. So now we have these 3 arrays of information. Our next step is that we want to turn this into a data frame so that we can eventually convert it into a CSV file. So can you scrape the image too? Yeah, the incredible thing about Beautiful Soup is you can scrape anything in the HTML. As long as you have like a proper selector. So let's see, classes forecast icon. So let's do that. So, images equals 7.findAll forecast image. That was it, right? Forecast icon. I'm useless at memorizing things short term. And then let's print it out. Yeah, see, now you have all the images. And then if you wanted to grab the source, you could probably do that as well. So to make that data frame, we just do, did we import pandas actually? We import pandas. So if this was an actual Python file, you would want to import it up here. But since I forgot to import it, I'll just import it down here. Import pandas SPD. Cool, so now we have pandas at our disposal. So we do df equals pd.dataframe. And does anyone remember what we want to put first in the data frame? It's kind of a tricky question. We want to put the column name. So if we're talking, if these are the 3 pieces of information we want to include in our table, we would maybe say day, and then that would be corresponding with the names array, which would which is like what was the period name, and then a comma, and then the temperature. Wait, the description was next. The description is descriptions, that is this array, and then temp is temps, and that was this array. And then note you need to put commas after each one that it's followed by another one. So now let's take a look at that data frame, and ooh, look at that beautiful scraped data. So if you wanted to, you could also do more string manipulation. Like, I don't love the way that this looks. Sunday night, all is one word. You could do string manipulation. And like I mentioned with data frames, you can also do a lot of data analysis on it. I won't be going over that, but like if you wanted to look into it, Pandas is really good for data manipulation. So then our final step is that we want to convert it to a CSV. CSV path for buff. Let's call it weather.csv, and then index is false. So we run that, and then if we go back, we can see our CSV. Ooh, wow, so pretty. So yeah, that is a complete example of using Beautiful Soup. So 3 steps again: investigation, grabbing the HTML, and then parsing it. There's a 4th part. I kind of lied. Part 4 is examining your data. So remembering to sanity check your data is super, super important because it's very possible that you grab something you didn't mean to. You'll notice that as I was scraping my data, I was double checking that I was actually getting what I was expecting. So that is good too. We also want to be checking at the end. So just assuming that your code is correct. When do we ever rely on that? I don't ever. I always assume that I've messed something up. So I always double check my work after I'm done with it. So like with this weather.csv, we can maybe look at like the first 3 entries and make sure that what we have corresponds to what we look like, we think we should have. So this afternoon, sunny 73, that looks good. Tonight, clear 54, also looks good. Friday, sunny 76, that looks great. When you have a lot of data, it can be harder to sanity check it, but like making sure that even a small portion of your data is correct can save you so much time. Are there any questions about the 3 steps or anything we've done so far? Will we be automating this? Not in this exploration session, but I'm sure it's optional, or it's, sorry, I read optional on the slide. I'm sure it's possible. So then here's our finished code. Part 2 was getting the HTML, getting the beautiful soup object. Part 3 was parsing through it. And then here was our results, if you want to look back at it. So I used Beautiful Soup recently to make an analysis of the critically acclaimed movie Twilight, which got 5.2 stars out of 10, to my sadness. As someone who was Team Edward before it was cool to be Team Edward and I was made fun of for it, I feel like I've never quite gotten the respect I've deserved. But just as like a silly example of what you can use web scraping for, I made this project where I wanted to answer the 2 questions: which actors acted the most projects after their appearance in Twilight, and what's the most successful movie they've been in since Twilight, excluding the other Twilight movies, because the last Twilight movie made so much money, like billions of dollars of money, I think. The way I accomplished this was by going to the Twilight IMDb page, which I seem to be frequenting quite often. You can see I've already clicked a bunch of things. But so on the Twilight IMDb page, they have links to actors' IMDb pages. So if you click on this, or even if you look at the HTML, you can see here, there is a link to Kristen Stewart's IMDb page where you can then, if you scroll down, you can see all the things that she has been an actress in. So for my questions, which actors acted in the most projects, what I did was I started off on the Twilight IMDb page, and then I collected all of the links to each actor's IMDb page, and then I made new Beautiful Soup objects out of those. So here's kind of the code. It's a little bit gross looking because of how they hid away their links. But yeah, so I just selected that A tag, and then I got the href of it, and I was able to just collect all those cast links so that I didn't have to manually collect all of them. And then you'll see down here in the blue spot, a blue box, I made new Beautiful Soup objects out of each of those links, so then I could process the data, which I guess is a little bit more automated than what we were doing previously, but it saved me a lot of time doing that. And I also had to go one step deeper because I needed to find the movie that had the highest grossing, highest movie gross. What's the word? For Kristen Stewart, I think it was the it was Snow White and the Huntsman. So I also had to go deeper into her IMDb page and everyone's IMDb page to find the cumulative worldwide gross, which was, that's a lot of money. And the idea behind this is that the web is, the internet is a web of pages, right? So each website has links to many other pages, and that might have information that you want to collect. So like with web scraping, you don't manually need to go to these pages. You can have Beautiful Soup go out into the realm of the internet and collect this information for you. Could you use Python to automate registering for classes? That's, I think UW blocks that kind of behavior. I've heard that like they don't really like it when people do that. I don't know. I've never tried. You probably shouldn't try either. You might get like a stern email from someone, or maybe even like more discipline. I'm not sure, but I have heard people doing it and they temporarily ban you. Oh my gosh. Yeah, so maybe don't get banned. And so here was my data once I collected everything. It only really took, I think, maybe like 10 minutes to run. I can't really remember, but like considering how many pages and how much information it processed, 10 minutes is very impressive. And so I was able to get all of this information in a CSV, which I could then process. And I actually ended up making charts too. So the highest grossing movie, the actor of the highest grossing movie was Gil Birmingham, who is Jacob's father. He's in one of the Transformer movies, which I found was surprising. I thought it would be Kristen Stewart or Pattinson or Taylor Lautner. And then the Twilight actor with the most projects was the biology teacher. So, and I created these using Seaborn and Matplotlib. These are Python DataVis libraries that are pretty useful. They're easy to get into, much easier than I think than like D3, which is a JavaScript library. So if you're interested in that, I have provided links to those things. I've also provided links to more information on Beautiful Soup. The Beautiful Soup documentation, she's a little ugly, but she works, right? There's other things that you can do with Beautiful Soup, and you can just find examples of that here. And then if you wanted to learn more about Python, there are also some links here too. So that is basically all the content I have. If you have any questions, you can ask them right now, ask them on Ed, email me, etc. Why is it called Beautiful Soup? That's a great question. Actually look this up. I think the idea is that HTML by itself is sort of ugly. It's a soup of ugly elements and classes and IDs. And Beautiful Soup lets you like parse through it so that it looks pretty. It looks beautiful. Yeah, it's nice. It's a nice sentiment. Yeah, any other questions? If you like Python, CSC 163 is the introductory to Python class. It's actually where I learned about Beautiful Soup. And Hunter Schafer was the one who taught it the last 3 quarters. It was a super interesting class. I would highly recommend it because Python is just so useful and very ubiquitous right now. Took it and changed your life. Wow. Yeah. Changed my life. Hunter is like the sweetest guy ever too. Cool. Well, if there are no other questions, I'll stop sharing. Pause the recording.